Okay, so today we're going to be balancing a redox reaction equation in a basic solution. And so the first step that we want to do is identify what is being oxidized and what is being reduced. So to do this, we have to look at the charges in this equation. So here, MnO4 has an overall charge of -1. SO3 2 minus has an overall charge of -2. Okay, so now we look at the product side, and we can see that this MnO2 has an overall charge of 0 because there's nothing here. So we can assume that's 0. And SO4 2 minus has an overall charge of -2. So from here, we need to see which of these elements, so is Mn on this side and this side being reduced or oxidized, meaning is it gaining or losing electrons? So oxygen always has a -2 charge, unless it's a specific case. But for the most part, oxygen always has a -2 charge. So we know, so let's write this over here actually, MnO4 minus. And so oxygen, since it always has a -2 charge, and we have four oxygens, we can multiply -2 times 4 to give us -8. So what is the charge of Mn in this? Well, we know that the overall charge of this whole reactant here is -1. So this charge here plus this charge here has to equal -1. So what does Mn equal to then? Since we know what the missing variable needs to be. So Mn will be +7, because +7 plus -8 is given -1. And so Mn has a +7 charge right here on this side of the reactants. Now let's look at Mn on the product side. So we know that this product has the overall charge of 0. So here, oxygen, -2 charge, and we have two of those, so we have a -4 charge on oxygen here. So what charge does Mn have over here to make the overall charge equal 0? Well, that's easy. That's +4. So we see that Mn is going from +7 to +4. And what does that tell us? Well, when it goes from +7 to +4, that means it's going down or it's gaining electrons, and that's why it's becoming less positive. And so now we can tell from this that Mn is being reduced. It is gaining electrons. Now let's just double check. So we already know that Mn is being reduced. So we could just kind of skip it and say that SO3 2 minus is being oxidized or losing electrons. But let's just double check because we never want to assume anything in these problems. So we have SO3 2 minus. So the overall charge of this is -2. And we know that oxygen has -2 charge. So -2 times 3, -6. And so we want to get an overall charge of -2. So what does S equal to give us -2? Well, S will equal +4. If S is equal to +4 charge and then O3 has a -6 charge, the overall charge will be -2, which is what we want. And so on the product side, we have SO4 2 minus. Okay. And so the overall charge here is also -2. Just wanted to double check. Okay. So we know that oxygen is a -2 charge, and then we multiply it by 4, because that is how many oxygens are in this element. So we get a charge of -8 for the oxygen, and we're looking for an overall charge, this product, to be -2. And so here, +6 for S will give us a overall charge of -2. And so now we can look at this, take a step back and see that S is going from +4 to +6. So +4 is on the reactants and then +6 is on the product side. And what this tells us is +4 to +6, it means it's losing electrons or it's becoming more positive. So if it's losing electrons, it is being oxidized. Okay, so the first step we have completed now. We have identified what parts of these redox reaction is being reduced and what's being oxidized. So now we can write our half equations and balance them accordingly. Let's first start off with the reduction. It's usually recommended to always do the reduction first and then do the oxidation after. But you can go in any order. It doesn't matter. So we will do the reduction reaction first. Okay. So we know that this in this equation, let me erase this so it's more clear. So we know that MnO4 minus and MnO2, this is what's being reduced in our equation, as we have determined here previously. So we can write this down here now. MnO4 minus, let's leave some space here because we will have to be adding some elements and to balance this out. So we're gonna leave some space and move this arrow a little bit more. And then on the product side, we're getting MnO2 with no charge. Okay, so first thing to do is we want to look at how many of each element do we have on each side and make sure everything has the same number of elements on both the reactants and products. So first we have Mn. We'll always look at the elements that aren't oxygen or hydrogen very first. So we're going to start off with Mn. So we have one Mn on this side, and then we also have one Mn on this side. So the Mn's are balanced. There is no uneven number of elements for that. Now let's go on to the oxygen, and this is where we will start having to add some. Now, for the oxygen, we have 4 oxygen on this side, while we have 2 oxygen on this side. So how can we balance this out? We can't simply multiply MnO2. We can't do that, as that'll make the equation more complicated. And that's not the proper way to do it. So how can we do it? Well, we can add H2O to balance out the oxygen. And since we have 4 on this side, we need to also have 4 oxygen on this side, and we right now have 2. So we can add 2 H2O. So we have 2 oxygen here plus 2 oxygen here. Right? So now we have overall oxygen is 4, which is equal to the other side. Okay, but after adding H2O, what we now also have is H's. We have hydrogen, and we have 0 hydrogen on the reactant side now, so we have to balance that as well. So we have 4 hydrogen on this side, and on this side we have 0 hydrogen. So we can simply just add hydrogen ions to balance the hydrogens. And we need 4 hydrogens. So let me move this a little bit. We need 4 hydrogens on this side, right? To give us 4. We can add 4 hydrogen plus. Okay, so now all of the elements on both sides are balanced. They have the same number. So now we have to look at the charges, the overall charges, and make sure all the charges are balanced out. Okay, so let me just make a little lighter here. Okay, so MnO4 minus gives us the overall charge of -1. Then we have 4 hydrogen plus ions. That gives us a charge of +4. So the total charge on the reactant side, or on the left side of the equation, is going to be +3. Okay. So over here we have MnO2. So that gives us an overall charge of 0. And we also have 2 H2O, which is also 0. So the overall charge on the right side of the equation is 0. But we need to have the equal amount of charge on both sides. How do we do this? Well, we can add electrons to one side to balance it out. So we see that we have a +3 charge here. So if we add a -3 or 3 electrons, we will get an overall charge of 0 on this side, which is equal to the right side of the equation. So up here, we can add 3 electrons. Okay, so now we have the number of elements on each side balanced and the charges balanced. So we have a reduction part done. Now we can move on to the oxidation reaction. So we know that the things that are being oxidized in this equation are SO3 2 minus, okay, leave some space again, then it's resulting in SO4 2 minus. The oxidation usually always goes much faster than the reduction balancing. So let's do the same thing, same process here. We have one S on this side and one S on this side. Now let's look at the oxygen. We have 3 oxygen on this side. We have 4 oxygen on this side. So we have less oxygen on the left side. So to balance it out, we can add an H2O, giving us 1 more oxygen. So now all our oxygens are balanced. However, now we have more hydrogens on the left side than we do on the right side. So we have 2 hydrogens on the left side. Now we need to have 2 hydrogens on this side as well. So we can add 2 H plus ions. Okay. So now all of the elements are balanced as well. Now we look at the charges. Okay. So we can see that SO3 gives us an overall charge of 2 minus, so minus 2, and H2O has a neutral charge. So overall, the left side of this half reaction is -2. On the right side, we have a -2 from the SO4, and now we have a charge of 2 plus from the hydrogen ions that we added. This will give us an overall charge of 0. So now what we can do is add electrons to the right side to give us a balanced charge of -2 on both sides. So 0 plus -2. This -2 represents electrons. Will give us an overall charge of -2, which is equal. So now both sides of the equation are equal. And let me go ahead and do electrons on this side. Okay, so now we have our balanced oxidation and reduction half equations. Now what we got to do is combine them. Okay, we have to have the same number of electrons on both sides. That way we can cancel out. So let me highlight this. Just move it down here. Oops. Okay. Save this equation and let me move this one as well. Copy. Okay. Let's just move this right here so we can see it clear. Line it up. Okay. So move this a little bit more down. Okay. So what we can see here with these balanced oxidation are, sorry, this is actually the reduction. Yeah, that's the reduction. This is the oxidation. Okay. So now we have our balanced half reactions. And so what we got to do now is look at the number of electrons we have on both sides. We can see that one side has 3 electrons and the other side has 2 electrons. And we need to have the same number of electrons on both sides so we can cancel them out. So what can we do here? Well, for this reaction, we can actually multiply this whole equation by coefficient of 2. And then for the oxidation, we can multiply it by a coefficient of 3. And so the intended effect from doing this is that we'll get 6 electrons on both sides when we multiply it out. Okay. But when we multiply by 2, we have to multiply everything by 2 as well. So we get 2 MnO4 plus 8 hydrogen plus 6 electrons, 2 MnO2 plus 4 H2O. for our reduction reaction. And for our oxidation, we're multiplying by 3. So we get 3SO3, 2 minus, plus 3H2O, 3SO4, 2 minus, plus 6H plus 6 electrons. Okay, now we can start canceling the electrons out and canceling anything else out we have. So we have 6 electrons in this and 6 electrons on the oxidation. So those will cancel out. Now we see we also have 8 H pluses on this side and 6 H pluses on this side. So we can cancel that out, and then we'll get a remainder of 2 H plus ions on the left side of the equation. And we also see that we have 3 H2O on this side and 4 H2O on that side. So by canceling out, will be 1 H2O will remain on the right side. Okay, so everything that is in common with each other has been canceled out. And so now we can write our overall equation. So we have 2MnO4 minus 3SO3 2 minus and 2H plus on the left side. Okay, I'll write this out. And so by writing this out, we're actually combining the oxidation reduction back together. And we have 2MnO2 here, 3SO2 minus, and 1 H2O. So it's very important on this part to make sure you don't get anything, you don't leave anything out, because everything matters. So I like to just circle it and make sure I have everything written down. 1 H2O. Okay, so if this was in an acid solution, then we would be done right here. However, this is in a basic solution, and we have 2 hydrogen plus ions making this equation acidic, and we need it to be basic. So what we can do is add OHs for this side to on both sides actually, but we'll add 2 OHs to balance out the 2 H plus, and then what we do on the left side, we also have to do on the right side. 2 OH. Okay, so by doing this, we can actually combine the OHs and the H plus to give us H2O. So we have 2Mn, O4 minus, these do not change. And so now we have 2 H pluses and 2 OHs, which will give us 2 H2O molecules. And on the right side, we have 2MnO2 plus 3SO4 2 minus plus H2O plus 2 OH. Okay, now one final thing to do is cancel out the H2Os because we have 1 on both sides. So we have 1 H2 over here, that cancels out, and the 2 cancels out here to give us 1 remainder. We have 1 H2O. So going back to what the question originally asks, it says to balance the following equation in a basic solution. So we've done that. And we have to give the coefficient of water based on this. So when we come down here, we can see that after balancing it out, we have a coefficient of 1. Thank you so much for watching.